Hello friends, welcome to Water Today YouTube channel, which is knowledge sharing channel, I would say. So today we are going to see one more interesting subject. I'm sure you would have seen the video on pressure boosting, and that was for water. But we said we will also talk a little bit about wastewater. Handling of wastewater has been really a tough job for many, but I'm sure we can make it easier for you and still you can handle wastewater better. But first of all, how do you define wastewater? The simplest definition which comes to my mind is if the water is not potable, then it is a wastewater. Which means if you cannot drink the water, then it is wastewater. So you can see how much of wastewater is being generated in this entire world. And handling that is quite a tough job, but we'll make it easier for you. First of all, you need to understand what are the different kinds of wastewater you have. And wastewater predominantly has solid particles. So the first and foremost is your pumps which you're buying should be able to handle some particle size. And how do I select this particle size? I'll just give you an idea about it. You can categorize wastewater into three, which is drainage, effluent, and sewage. A drainage is nothing but, for example, your car park in the basement, where you will have about 10 to 15 particle size. If you go to the next, which is effluent, which is predominantly in the industry, you will get about 35 to 45 of solid size. The toughest one, the sewage, you need minimum 80 of passage for pumps. So first identify whether you're going to handle drainage, effluent or sewage. Then remember this 15 to 20 particle size, 35 to 40 80 and above for sewage. And you can say one thing like you can put a sewage pump in effluent, but never use an effluent pump in sewage, because that is where it leads to clogging. And why this particle size and why they have given it is if you put a graph towards the number of clogging and the amount of time it has worked. In a sewage application, if you don't have that 80 passage, then your clogging risk is very high. So that's the reason why you need to have minimum 80 particle size. Okay, the next question comes like, I have some vortex impeller pumps. Yes, you can take a vortex impeller pump, but minimum 65 and 65 also on the commercial side, but not on the municipal side. When you go to the municipal side, it should be above 100 or even 150 The larger the handling capacity of the pump, the better it is for you to handle sewage. So first, drainage, effluent, sewage. Now you narrow down, like if it is a drainage, you just need about 15 to 20 particle size, and you have very compact pumps today available in the market, which are very handy, and you can lift it and put it wherever you want to dewater it. Or you can also make a permanent solution to your basement car park. If you know that it is going to get flooded in the rainy seasons, then you can make a permanent station to it. And effluent, you be very careful when you are doing it, and temperature plays a very important role when it comes to effluent. So always take the temperature into account. Sewage, particle size is the major one, and all this happens, how it happens, like you flush your toilet and then it moves down, it moves into the shaft, then it comes here, and if you are connected to a sewage line, then it goes directly to the sewage line. But if you are not connected to a sewage line, or you want to collect the sewage and take it to a treatment plant, then you need to have a pumping pit or a sewage pit. And that pit has a lot of design aspects to it, because I have seen it in many places that people don't follow this and end up saying that the pump is not, and always the pump is to be blamed for anything. So they say the pump is not working and the pump is at fault. But whereas when we go to the site and see, we see that the pumps are lying down and they are kept close to the wall, they are kept away from the wall, they are not taken, they lifted the pump very high. So all this parameter put together is a major cause of failure when it comes to sewage handling. So we will also see how we can handle all this sewage. And as we discussed in the pressure boosting, we saw about building codes and where you can get the charts and discharge units and calculate how much of peak demand you need to have. The same, exactly the same way, you can also do it for sewage. And the thumb rule more predominantly is that if you give 100, 80 comes out as wastewater. So if you are pumping 100 liters of water, 80 liters will come back to you as effluent or as sewage. So you need, or grey water, black water, so whatever you call it, you name it, then you need to do the treatment also according to that. But you can also calculate how much of wastewater I am generating by using these tables again. Just get back to Uniform Plumbing Code, you will get a lot of insights into it, and there are tables available from where, by using the fixture method itself, you can calculate how much of wastewater I'm going to generate, and if I'm going to generate so much, how I'm going to accumulate it, and if I'm accumulating so much, what should be the size of my treatment plant. So you can decide everything. So it is possible if you get into Uniform Plumbing Code. Now that you have decided everything, and then you have made a pit, and I want to have some pumps into the pit. Fine, how I'm going to have that pumps? For example, I want to put 3 pumps into the pit. Fine, 2 working, 1 standby, absolutely fine. But you have to decide like where I'm going to put it into the pit and what should be my pit size if I have to put 3 pumps into it. What I'm talking about is not in individual villas or something, but in commercial establishments or institutional, you get this, and you will have at least about 3 pumps, 2 working, 1 standby, or sometimes they have a redundant system, 2 working, 2 standby. But how do I put all this into this? Positioning the pumps into the sewage pumping pit is one of the most important things if you want your sewage pumps to last longer and longer. What I'm saying is, if you follow all this, even your sewage pump will work for 15 years without any problem, and you do the normal maintenance what is prescribed by the manufacturer. The first and foremost is that what should be the center to center distance between the 2 pumps. Then there are Hydraulics Institute which gives you this. You can't put it further away, or you cannot put it close together. You need to have this center to center distance maintained. For example, when you take a sewage pump, I'll also put a picture to it to tell you what is the volute. Volute is nothing but where inside you have the impeller. The volute size makes a lot of calculations easier. So if I take D is the diameter of my volute, the center to center distance between the 2 pumps should be minimum of about 2 times the diameter. And from the wall to the center of the pump, 1 time the diameter. So if I'm going to put 3 pumps into it, 1 diameter, 2, 2 and 1, which is almost equal to 6 times the diameter of the volute. So that will be the minimum size that you will require. And after that, on the sides, you need to do some benching to bring all the sewage into the pump for it to pump it out. So you can have a larger pit, but you have to maintain all these distances, and you also have the benching done so that you bring all the sewage into the pump so that the pumps can deliver. And the most important thing what you need to look at also is the start and stop level of the pumps. You need to calculate like how many starts and stop I can have, so that you give ample time for start and stop. And never ever do hard stops. Hard stops, I mean, is switch off the pump and immediately switch on the pump. Never do that with a sewage pump. What happens is when a pump is operating, it is keeping on pumping into it. Once the pump is switched off, the water in the line comes back into the sewage pump. And if you switch it on again, both this are in a different direction, in the completely opposite direction, where over a period of time you will see that you will have the bearings going, the shaft seal going, and the shaft itself sometimes breaks. So never use a hard start and stop in a sewage pump. You need to allow for the pump to settle down, and the reverse rotation of the impeller has to settle down, and then only you can switch on the pump for that matter. So what should be the start and stop? See, it all depends on what kind of pump you are getting. Today pumps are available with cooling jackets, which means that even if you pump it low, just above the volute, you can still pump it if you have a cooling jacket. But if you don't have a cooling jacket, it is always advisable to completely submerge the pump and have your low level just above the complete height of the pump. So the start level, the stop level, you can also have an alarm level, and this is how sewage pumping operates, and you should be very careful about having the right levels inside the pumping pit. So I'll also give you a brief about what we have been talking visually to you, so that you understand about the start, stops, and center to center distance, the benching, and what should be. Many people ask me, like, where should I put the sewage pump? Can I put it right on the floor? No, please don't put that right on the floor, because you are not allowing space for the pump to suck what it needs to do. So you need to put it a little up. What is that little up? It is nothing but I always say it should be minimum 100 mm or half the diameter of the volute, whichever is higher. So you need to have this minimum 100 mm from the bottom, and never put the pump very like you take it 1 meter above. And I have seen this people doing, like taking it above, saying that there will be sludge accumulation, so the pump is not going to get immersed into it, so we put it 1 meter up. Again, you are killing the pump. So never put that like that, because your sewage pump is there to handle all that sludge. And if you start handling right from the beginning, you are not going to have sludge. But if you put it on the top, all that sludge will be there, which is not a good design at all. So, but what happens? There are some places where you want to change the pumps. So, what do you do first? The first, immediately as a plant manager or the utility manager, he wants us to have very reliable pumps and everything, but you can change the pump. It's not only that you only need to change the pump. In today's scenario, there are so many sensors which are available, and you can also communicate with the pumps. So you put some sensor. So what is that sensor I'm going to have? I'm going to have some level sensor, which can be ultrasonic level sensors. And predominantly people don't use the probe here, because the probe gets stuck with the sewage and it doesn't give you that, but ultrasonic works much better. You just see that, and so that you have that sensor. And in the pump you can also have water and oil sensor, temperature sensor, vibration sensor. So all that, however you need it, you can put some sensors. Once you put some sensors, you can also have a panel into which you can see like how many hours this pump has been working, and how many pumps have been working in total, and you can put it in cyclic operation and see how this are performing. So you will have complete data about this sewage pumps, and having data about the sewage pump is very, very important. So you can put controls, then you can have some communication modules where you can communicate with the pumps. That is again more important. And I have seen places where the pumping station has about 8 pumps, which are all 240 kilowatt, 250 kilowatt pumps, but there is not a single person in the site any day. It is all taken to the SCADA system, and from there they monitor. Only when there is a fault indication, the guy comes into the pumping station. Otherwise, the pumping station is closed and locked. So you can do automation in a pumping station to that extent. Only that we need to go through it ritually and decide like what is the kind of automation I need. And the level of automation is very important. Some of the things which you won't use at all, please don't do it. But what I need important, please do it. And that is how you can save the pumps. You can schedule your maintenance. You can see alarms. So everything can be done once you have this communication. And sometimes I also advise like you can put a submersible mixer into it, and the mixer starts before the pump starts, so that all the sludge and everything, it suspends it, and it is easy for the pump to take it and pump it out. So the level of automation, especially now people are moving towards BIM and SCADA and so many things. So, and industry is moving into IoT 4.0. So when we put all that, you also need to take care of your sewage pumping station to exactly know what is happening here. So it's not only about the pumps, but it's also about the level of controls and the monitoring and the system that you can provide for a sewage. Once you have complete this package and you have everything in place, I'm sure your sewage pumps are also going to work for more than 15 years with the normal maintenance as scheduled. For example, if you say there should be some oil change after 3000 hours of operation, and if you can do, say, how many hours my pump is run, you can definitely plan for your maintenance. So going with this later, when in the water side, when we talked about pressure boosting, we said you can have fixed speed control, we can have variable frequency drive, and there are some automations you can do. You can cut in, cut off, and now pumps are coming with IE5 motors, and they can also sense how much of the friction resistance it has in the line and adjust the pump according to it so that it always works in the BEP. And one more question which comes to me very often is, can we use VFD in a sewage pump? In that, I would like to caution you that you need to be very careful if you need to use VFD in a sewage pumping line. Because one thing is, when you pump sewage, you need to have a certain velocity in the pipeline, which is called the self-cleansing velocity, which is 0.7 meters per second. And it always has to be above that. So if you're running a sewage pump on a VFD, you might not get this velocity into it, or it cannot push it. So the total head, the georetic head, the static head, everything comes into play. So you need to have some calculations done, and as a rule, what they say is, if the georetic head is less than 40% of your total head, then your VFD will work. If it is not or greater than that, your VFD is not going to work. So when you think about VFD in a sewage pumping operation, you can think about it when you're doing a starting or something, but you need to be very careful about using the VFD on a sewage pump. So get in touch with the experts and they'll be able to give you more information on it. So thank you so much for your patient listening this episode. Please subscribe and push the bell icon, and also don't forget to visit h2obazaar.com, where you get a lot of innovative products, and also the Expo of Water Today coming up soon. We'll all meet again. Thank you so much.